Good morning, students. Today we are going to learn the topic called postulates of modern atomic theory from the lesson Atoms and Molecules. Let's go for some basics. We know that every matter in the world is made up of atoms. The fundamental particle of matter is an atom. We cannot see the atom through our naked eye. That means the atom is very smallest particle. Hence, we conclude atom is the smallest particle. Up to 18th century, the scientists believed that atom was considered as indivisible particle. In fact, the word atom comes from the word atomas. It is a Latin word. It means incapability of being cut. That means atom is an indivisible particle. But you have studied in your ninth standard that the atom can be divided further. They are found out the subatomic particles are called electrons, protons and neutrons in it. After the discovery of electrons by J.J. Thomson through cathode ray tube, proton by Goldstein and neutron by James Chadwick, the atom is divisible now. So, atom is considered to be a divisible particle now. In other words, atom is no longer indivisible. Let us come to the next point. This topic also we studied in 9th standard. Here the word isotopes. Iso means similar. T. Come to the next letter. T, we can remember this. T indicates the top number is different. Okay, we will understand with an equation. Before we go into the topic, we should know the representation of an atom so that it will be very easy. Generally, the atom is represented by X, the symbol of an atom of an element. Z is the atomic number, which is either number of protons or number of electrons in a neutral atom. A is a mass number, which is sum of number of protons and number of neutrons present in a nucleus of an atom. Now, let's see with an example. Cl is the symbol of chlorine atom. 35 is the top number, that is mass number of chlorine. 17 is the bottom number, which is an atomic number of chlorine. Now see the example for isotopes. The chlorine element has two isotopes. One is Cl35 and other one is Cl37. Cl is a symbol. 17 is atomic number, 35 and 37 mass numbers. Compare these two atoms. They have same atomic number but differ in their mass number. So what we can conclude from their statement? Atoms of same element have different masses, even though atom of same element may have different atomic masses. Come to the next point, isobars. What do you mean by iso? As I said earlier, which means similar. Next letter B is the bottom number is different. Which is bottom number? You're right. Atomic number is the bottom number. Look at these examples, argon and calcium. Ar is the symbol of argon. 18 is the atomic number of argon. 40 is the mass number. In calcium, Ca is the symbol of the calcium. 20 atomic number, 40 is mass number. Look at the bottom number. The atomic number is different in both cases. What about the mass number? The mass number is similar. Even though the atom of different elements, they have same mass number. So we conclude this, the atom of different elements may have same atomic masses. Come to the next one. Let us understand the concept with an equation. Uranium 235 is a radioactive isotopic element. Uranium is bombarded with slow-moving neutrons. The resulting atom will be uranium 236, which is unstable because the nucleus is very heavy. So, it's automatically split into barium and krypton and 3 neutrons along with 200 million volt. Such a huge energy is released in this process. What we have learned from this equation so far, one atom cannot be converted into another atom. But what this equation says, uranium atom is converted into barium and krypton. So one atom of an element can be converted into other atom of an element. So what is the conclusion? Atoms of one element can be transmuted, that means transforms into trans atoms of other element. This process is called artificial transmutation. What is the one more point this equation says? Atom is indestructible. Uranium is destroyed to form new elements. That is, an atom of one element can be destroyed to form new elements. In other words, atom is no longer indestructible. Let us move on to the next point. Ratio of atoms in a molecule. We all know very well water molecule. The atomic ratio between the hydrogen and oxygen. What is meant by atomic ratio? The number of atoms of hydrogen, number of atoms of oxygen. If we take a ratio between that, the atomic ratio between oxygen and hydrogen in water molecule is 2:1, which is simple ratio. Next example, formula for glucose is C6H12O6. The atomic ratio of carbon, hydrogen and oxygen is 6:12:6. Is there any common number to divide? Yes, the common number is 6. If you simplify this, we will get it 1:2:1, which is also simple ratio. Come to the next example, sucrose molecule. The formula is C12H22O11. The ratio is 12:22:11. Just think, if there any common number to divide, 12 and 22 we can be divided by 2, but 11 we can't. 11 and 22 we can divide by 11, but 12 we can't. So there is no common number, so that the ratio is 12:22:11. Definitely. This is not a simple ratio. So the first two examples have simple ratio, whereas the fourth one has a complex ratio. What is the conclusion we are having from this statement? Atom in a molecule may not always combine in a simple whole number ratio. There may be a complex ratio. If you take a DNA, RNA or amino acid, the ratio is very, very complex. Come to the next point. Atom is the tiny particle that takes part in every chemical reaction. Come to the last point. The mass of an atom can be converted into energy. In the fourth point, we have see that uranium atom has a particular mass. When uranium atom is attacked by alpha particle, it gives huge amount of energy. From this we understood the mass of an atom can be converted into energy. I hope you all understood. Thank you.